This question is related to de-Broglie wavelength. There is an electron microscope, and electron beams are used in that electron microscope. And these electron beams are accelerated with the potential difference. Say for that potential difference, like between some two plates, or like V. Now, due to this, the electrons are going to move, and that will produce a matter wave. It will have a wavelength. So the wavelength of a matter wave can be written as h by p, where p is the momentum. Momentum we can write in terms of energy. So let's consider, say, for kinetic energy, which is equal to p squared by 2m. Now, like let it be e. So if you want to write momentum, it will become under root 2m e. So I can write here under root 2m. Here, the energy is given by the potential difference and the charge. So I can write E equal to energy equal to E into V, where E is the charge of electron, V is the potential difference. So our lambda is becoming h by under root 2m EV. Here, this h2me, everything is constant except this V. So I can write this as C by, where C is some constant. It's not speed of light, it is some constant. In the first case, what we are having is lambda 0 for the potential difference of 20 kilovolt. I'll write it 20 kilovolt. In the second case, instead of 20, like we are using 40 kilovolt. So it will become under root 40 kilovolt. Now this 40, we can write it as root 2 root of 20 kilovolt. So this part, the C by root of 20, I can write it as lambda 0. So when we use 40 kilovolt, the de-Broglie wavelength becomes lambda 0 by root 2, where lambda 0 corresponds to the de-Broglie wavelength of this 20 kilovolt. So option 4 is the correct.